Good afternoon. Today I'll be presenting information from a review of recent eastern spotted skunk camera surveys and research. I want to start out with acknowledging my co-authors, David Chakowski, Stephen Harris, Luke Dodd, Andrew Edelman, Summer LaRose, Robert Lunsinger, Blake Sass, and Max Allen. Additionally, we want to thank the Eastern Spotted Skunk Cooperative Study Group for the data they helped to provide, as well as some of the members listed here that have provided us with data from ongoing studies. Additionally, we want to thank Colleen Offenbottle and the North Carolina Wildlife Resources Commission for logistical and funding support. The idea for this research was presented at the 2020 ESS CSG meeting in Athens, Georgia. The group wanted to compile testing methods to see what has been effective to better understand and improve research methods in the future. We've had a bit of a time getting this paper accepted. We first tried the Southeastern Naturalist Special Edition, then we went on to the American Midland Naturalist, and now we are on to the Journal of Fish and Wildlife Management. The general feedback we've been given is that our paper is too methodologically focused. We think this paper does have quite a bit of useful information, especially for field staff and biologists that are developing their own study. We'll discuss some of the more analytical issues that we ran into in a later slide. The eastern spotted skunk was once widely distributed throughout much of the central and southeastern United States, but has since experienced range-wide decline since the mid-1900s. Subsequently, the eastern spotted skunk has become a species of concern for many wildlife agencies and organizations in the United States. Historically, most eastern spotted skunk presence data came from harvest, museum, and pelt purchase records. Over the past 2 decades, however, eastern spotted skunks have been more commonly reported through track plate and camera trap studies, incidental live trapping, and roadkill reports. In the first documented study to assess surveying techniques for eastern spotted skunks, Hackett et al. Compared the efficiency of non-invasive enclosed track plates and baited camera traps to detect plain spotted skunks in Arkansas and Missouri. Results indicated that track plates had a higher probability of detection and a lower latency to initial detection than camera traps. However, camera trap technology has advanced greatly since that study. Camera trap-based surveying now has multiple advantages, including the ability to make positive identification of animals based on obvious visual cues. Camera traps can provide temporal information and information on the number of individuals that visited a site if pelt patterns can be detected. While the initial investment in cameras can be high, camera traps provide a surveying technique that can be long-term and large-scale while using minimal staff that can pay off in the long run. Currently, 19 of the 28 member states of the Eastern Spotted Skunk Cooperative Study Group have used camera traps to conduct surveying methods for the Eastern Spotted Skunk. Since the recent surge in researching the Eastern Spotted Skunk, cameras have become the predominant non-invasive sampling tool among biologists. With the recent increase in camera trap-based research for this species, our objectives were threefold. 1, to summarize and compare common methods used for detecting eastern spotted skunks using camera traps. 2, suggest best camera trap monitoring practices for this species. And 3, propose a future framework for range-wide monitoring. To compile a comprehensive list of studies using camera traps aimed at detecting eastern spotted skunks, we conducted a literature search of studies published through August 2020. Secondly, we contacted all members of the Eastern Spotted Skunk Cooperative Study Group and individual experts and state biologists in each state to obtain information from past survey efforts that had not been reported in the primary literature. We attempted to collect information on the proportion of sites where detection occurred, latency to initial detection, and available information regarding 3 main aspects of study design that we predicted would affect detection of eastern spotted skunks: seasonality of detections, bait and lure combinations, and camera trap brand. We did omit 2 studies in Wyoming, where more recent studies suggested that there are likely no eastern spotted skunks, and we also omitted the camera trap study conducted by Hackett due to a 7-year time difference, resulting in significant improvements in camera trap systems between this study and the first succeeding study starting in 2014. We defined multiple terms to accurately describe and analyze the impacts of study design. So site detection rate was the number of sites where detections occurred divided by the total number of sites surveyed, made into a percentage. Survey duration was the first camera set to the last camera pulled of the entire project. Camera trap deployment was the number of days a camera trap was deployed at a site within the survey duration. Latency to initial detection was the number of days until the very first detection. Bait was a food item that could be accessed and eaten. Lure was something that was odorous and non-consumable or non-accessible for consumption. Before we dig into the results and analysis, I do want to acknowledge some issues that we ran into that may lead you to wonder, where are the p-values? One of the issues we have run into while trying to get this published is a lack of statistical analysis. Although we made our best efforts to find some significance, we quickly realized that the data we compiled was very messy. I've included a snapshot of some of our data for reference. First, we ran into the issue that we had an uneven comparison of studies. While we reviewed 16 studies, not all of the studies reported all of the same metrics, and some didn't have data to report at all. We also had studies that left the cameras out for the duration of the study and others that moved cameras around during the survey duration. So it was difficult to analyze the latency to first detection. There was not a set definition of what was considered a detection, so we could not evaluate how many skunks were observed. And since this data is so new, we had a very small sample of studies to review. I would also like to acknowledge that we did not include habitat variables and that some of these studies were truly a shot in the dark, meaning that they could have been looking for skunks in an area where there were in fact no skunks. We included one reported study that had no detections. We were very careful not to data dredge here. You can see in the data that we were often given ranges or estimates, making this a very challenging process. 16 camera trap studies occurred in 10 of 28 states within the known historical distribution of eastern spotted skunks. Studies were conducted for a variety of reasons, including occurrence, occupancy, and to evaluate field sampling methods. 3 studies deployed camera traps for the entirety of their survey duration. Most studies had multiple camera trap deployments during the duration that averaged between 7 to 45 days. The highest percentage of detections occurred in March, followed by February, and then January. Just to clarify again, only one picture of a skunk was needed to count as a detection. So these numbers do not indicate the number of skunks detected. Rather, is that at least one was detected. This is a graph of the proportion of studies in which camera traps detected one or more eastern spotted skunks. So you can see here in March that we have a much higher proportion of detections. There was one study that had cameras out that did not get detection in that month. But you can also see in January, February, March that we have generally more studies with cameras out. But you can see as these proportion changes as we move through the months. So I like to look at this in a bit of a different way. In this chart, you can see the dark orange is where detections occurred and the light orange is when they were surveying and did not have detections. The 2 lines here show the initially recommended months to survey. You can see that many surveys studied during this time, but when they did, all of these studies that did survey got at least one detection. Again, this shows the highest detection in March. It's also interesting to take a look at the Lossinger study and the Lombardi study. So Lossinger here, Lombardi here, that's South Dakota and Virginia. These studies had detections in the summer months, which was somewhat of an outlier. Increased detections in January through April may be attributed to increased movement during spring breeding season or greater willingness to feed on baits or investigate lures due to decreased food availability in winter months. Additionally, longer nights may provide more hours to detect a nocturnal species. However, some of our studies have had success detecting eastern spotted skunks from June through August. Sampling during some summer months could reduce the detection of dispersing individuals or wide-ranging males searching for mates, which can help prevent violating the closer assumption inherent in occupancy models. However, a major reason for not including baited surveys during seasons outside of winter is the preservation of bait. Black bears can quickly consume the bait, thereby constraining researchers to conduct camera trap surveys during the winter when they're less active. Additionally, baits tend to have slower decomposition in the winter months due to the colder temperatures and fewer insects, allowing for longer periods between rebaiting. 14 studies reported latency to initial detection ranging from 1 to 82 days, with a mean of 17.1 days across studies. Studies that moved camera traps had a mean latency to initial detection of 14 days. The 3 studies that did not move their cameras had a mean latency of initial detection of 28.7 days. This may indicate that leaving cameras out longer may increase detections in the long run. Of the 16 studies we surveyed, 7 use a combination of bait and lure, and 7 use bait only. You can see the average site detection rate listed next to the label in the first chart. Of studies that use bait, 75% use canned sardines either alone or in combination with meat or non-baited sites as controls. None of the studies directly evaluated the effectiveness of multiple bait types within an individual study, limiting our ability to control for site or population specific factors and adequately compare bait types. The highest average site detection rates came from studies using sardines in a non-baited control site. But as you can see, all studies using sardines had a higher site detection rate than studies that didn't use baits. The most utilized lure was fatty acid scent tablets. Besides that, a variety of lures were used across the project. The studies using lures alone reported site detection rates of 6.3 and 1.7. In general, the variety of baits that have been successfully used to attract eastern spotted skunks to camera trap sites support previous trapper reports that this species is susceptible to a wide variety of baits. By contrast, lures or scent-based attractants do not appear to improve detection probability for eastern spotted skunks at camera traps. Here's a graph of the average site detection rate of eastern spotted skunks for studies using certain camera trap brands with sample sizes in parentheses. Moultrie and Bushnell cameras were the most utilized camera trap setups, followed by those that use Reconyx, a combination of camera brands, or Brownings. Multiple models of camera traps were included in each brand, but were not reported in all studies. Of the 16 studies that reported both camera trap brand and site detection rate, studies using Bushnell tended to report higher average detection rates per site sampled. It's important to evaluate and test your camera before use. Based off of Inge's study, spotted skunks spend less than 9 seconds in front of the camera, so you need to have a camera with quick trigger speed. Additionally, spotted skunks are nocturnal, so having a low or no glow infrared camera is important. Again, no significant values to support this, but Bushnell seems to be the best so far. Our biggest recommendation is to test your cameras before buying a bunch of them and putting them in the field. This picture is my test model for a weasel project. I made my weasel size tester out of beans, put it in the microwave so the heat would trigger the camera, and made sure the camera was capturing what it needed to. Also, everyone has squirrels, and they are just about the size of an eastern spotted skunk, so you can use them. Another issue that I've talked about in the past, and that I can elaborate more in the Q&A, are some unofficial and published studies that tested detection zones on cameras. Know where your detection zones are with your camera. Make sure you are focused on the area you need to be. So here's the most useful information and recommendations from our findings. The most productive time to set traps is from January to March. Run cameras for at least 17 days. Use sardines or at least some sort of bait. Set bait at a height less than 1 meter and at least 3 meters away from the camera. Research your camera trap models and brands. Understand your detection zones. Test your settings before and test on similar sized animals. Everyone's got a squirrel in their backyard. Use them. And finally, one of the needs we discovered while working on this paper was developing a range-wide surveying framework. We believe in order to truly get a good sense on the distribution and other population information on the eastern spotted skunk, we need to combine efforts in a standardized way. So here's what we propose. Develop a grid-based sampling frame across the species range where units are sized to encapsulate movement of an individual and meet common assumptions of closure and occupancy modeling. 2, utilize a generalized random tessellation stratified survey design to create a spatially balanced subsample of priority units to survey based on a range-wide species distribution model, predicting the probability of encountering eastern spotted skunk within a given unit. 3, have each participating organization then identify which units to incorporate into sampling based on rankings within that survey region, as well as logistical issues such as physical access to proposed units and resources available. 4, deploy camera traps within a selected unit using settings and timing that is consistent across units. And 5, revisit units at a specified interval to assess long-term patterns in distribution and attempt to estimate colonization and extinction probability. This obviously would be a big undertaking, but we believe useful in both developing adequate methods of surveying and conducting a large-scale study of the eastern spotted skunk. Again, I would like to thank the co-authors on this paper, especially for putting up with my incessant emails and requests for data and editing. Thank you for your time, and I'll be happy to answer any questions during the Q&A session.